now that you have heard all the bad and evil and insecure of all the passwords and password managers, let's shift gears a bit and talk about a thing that may throw all these stupid things away. So this is called single sign-on service. So in this presentation, I'm going to show you how secure the present single sign-on integrations are. So this work is done with my advisor, David Evans from University of Virginia. So single sign-on service, in case you haven't heard of it, is a type of service that enables the user to log into multiple applications using only one single account. Presumably, this is your social network account, such as Facebook or Twitter. So how to integrate such a thing into your application? Here is a typical workflow. So basically, let's say the user Alice, in this case, the green one, she tries to visit ESPN.com, and she would like to log in with Facebook to ESPN.com. So she first visits ESPN.com, the integrator, and then the integrator will redirect the user to the identity provider site, in this case, the Facebook. So the user, Alice, will then log into Facebook. Facebook would then issue Alice a OAuth credential. Alice would then forward this credential to the integrator, ESPN.com. And after ESPN.com confirms the validity of this credential, either by verifying the signature of a sign request or directly contacting Facebook, after everything checks, the integrator will authenticate the user as Alice. So as you can see, this is a non-trivial process that is hard to get right, actually, for an average developer. Therefore, major identity providers have created these documentations and SDKs to help integrators integrate such a service. However, we think that there is a dilemma here that these SDKs, they're designed for developers with little or no security expertise. But the secure integration depends on actually understanding important security requirements. So therefore, this has opened up a lot of opportunities for attackers to exploit a vulnerable application. I'll give you an example. So in this case, full application on the lower left corner, it is the vulnerable party, and the attacker, malware, is the malicious party. And let's say that the malware successfully lures the user Alice to visit his or her site, and then asks user Alice to log in through Facebook. Let's say Alice does just that, so she's going to follow the similar workflow, and then she forwards the OAuth credentials to malware. In this case, malware will simply try to reuse these credentials, give it to full application server. And the full application server will incorrectly identify malware as Alice if it doesn't check these two. Basically, the application ID to which the access token was issued, or the signature of the sign request credential. And if they don't check this, there will be a serious impersonation attack, as seen here. If the developers are careless, actually, they can not only hurt their own application, but they can also hurt users' Facebook account or Facebook themselves. In this case, you can see dealchicken.com. It redirects user to a landing page and asks the user to finish the registration process after the user has the first time used the single sign-on. But the user's access token is displayed as a query parameter in the URL of this page. So when this happens, and if this page hosts any third-party content, let's say a third-party image, the request to obtain this resource will automatically append user's access token in the referrer header. So in this case, it just voluntarily leaks this access token to an arbitrary third party. And when this access token bears dangerous permission, such as posting on user's behalf, then this could get ugly in a hurry. So because these vulnerabilities do happen, we want to build a tool which we call SSOScan. The tool takes in a URL and will be able to output the vulnerability status of 5 vulnerabilities, 3 of which I've already explained to you. So there's also another property that we want SSOScan to have, is that it must be able to finish the test for each site in a very short period of time, so that we can do a large-scale study on not only one site, 2 sites, and many, many sites. So SSOScan does that by using enroller first to register 2 test accounts at target web application. And the enroller, this involves finding the correct button to click to trigger the single sign-on process, automatically log into the identity provider, and also finish up the registration process if any ensues. And then it will conduct an oracle to verify that the enrollment has succeeded. And then finally, it will call a vulnerability tester, which will simulate impersonation attacks, and then will conduct the oracle again to confirm the session identity. So let's go into a little bit more details about how this is done. So first of all, this is how enroller can find the correct button to click. This is a screenshot of the Huffington Post website. In this case, SSOScan needs to click the upper right corner login button marked in red. So we use a simple heuristic to obtain initial list of candidates for SSOScan to attempt to click. Because the login button is often represented as a DOM node that has login, sign in, or join, these kind of word in them. So basically, we do a regular expression match, and we'll obtain a list of candidates. However, the list of candidates may be very long, and if we want to try every one of them, it may be too long for us to test many applications. Therefore, we have multiple heuristics to reduce, quickly eliminate this list to click the correct element. This is one of them. So we've actually found out that the location of the button is very important, that a lot of the applications would have their login button on the upper right corner of the page. And after you click on that button, it will pop up this overlay, and then you have to click somewhere in the middle to trigger the single sign-on process. We've actually done a heat map of all the correct clicks. As you can see, the first click almost exclusively happens on the upper right corner. But the second click is more spread out, but almost happens on the middle part of the page. So using this heuristics, we're able to weigh the candidate differently, and therefore, hopefully, SSOScan can get to the correct element in a short period of time. So I've also mentioned that some website asks the user to fill in additional information after they have used single sign-on to sign in for the first time. This is an example. And in this form, some fields have already been pre-populated using users' Facebook information. But there is also this email field that is left blank. So SSOScan will try to figure out what information to fill in that blank, and automatically does that, and then we'll try to find and click the submit button on this form. So now that it has done everything, it will consult an oracle, and this oracle is used to confirm the session's identity. And it does that by relying on the assumption that the home page will display some user information after the user has logged in. And normally, they will replace the original login button with the user information. As you can see in this case, foxnews.com replaced the original login button with our test account's first name. So that concludes my description of how SSOScan works. And now let's talk about the large-scale study that we did using SSOScan. So basically, we took the top-ranked 20,000 US websites according to Quantcast, and we exclude some hidden sites and DNS errors. That leaves us with 17,913 websites in total. Of these sites, SSOScan is able to detect 9.3% that has Facebook single sign-on integration. And of these 1,660 sites that use Facebook single sign-on, 12% are misusing credentials, 8.6% is leaking credentials. There are also 2.3% of the application that they have a very buggy implementation that nobody is able to log in with Facebook to that site. So there are also 20% of application that SSOScan is not able to complete the testing, It is mainly because they either ask the user to have an existing account and to link it with a social network account, or the assumption that our Oracle relies on, the homepage displays certain user information, is not true. So for more information, you can look at the paper. But the bottom line here is that 20.3% of the sites have at least one vulnerability, and these include several sites that have both of these vulnerabilities. So that is a very high number, I think. And if you look at the example of vulnerable cases, this includes some of the sites that people are using on a daily basis, such as Answers or Match.com. That's pretty bad for Match.com. And so let's now look at some statistics about the result. So first of all, this is a Facebook single sign-on support versus sites ranking. So on the left side, we have the most popular sites, and on the right side, we have the less popular sites. And the vertical bars means how many sites support Facebook. And as you can see, the trend is going down. This is kind of expected because we think that the more popular sites would try to integrate single sign-on more. However, when you look at the vulnerability status graph, you can see that the average line is actually kind of flat. And this is kind of surprising because we thought initially that the higher profile websites should have a better security practice and should be more careful about integrating single sign-on. But the fact is actually this is not true. And this shows that the higher profile website actually do not seem to have a better security practice, at least in terms of single sign-on integration. So we've also tried to break down whether different integration methods would have effect on the vulnerability rate. So basically, we've classified the integration methods to 3 types: using SDK, using widget, or they don't use any of these, which we call customized code. And as you can see in this table, that using widget or SDKs, they have a much higher possibility of credential misuse, be vulnerable to credential misuse attacks. And using customized code, actually, they are more susceptible to credential leakage vulnerability. And we think this happens because SDK and widget, they automatically expose access token and sign request to applications backend server without doing any validation on the client side. And for the custom code, the default way of passing the OAuth credential back to the application server is to append it either as a document fragment or a URL query parameter. So this makes the application more vulnerable to the credential misuse vulnerability if they are careless. We think that this result will give some insight to the identity providers as to how to develop their SDKs and documentations to lead the developers to the correct way. So finally, this is some responses we got from the vendors. We've actually contacted 20 vendors, 20 vulnerable vendors manually, and we've only got 8 responses, and only 3 out of this 8 responded after the initial automated response. So there's only actually 1 site that took any action at all, and this is ehow.com. What they did is they actually removed single sign-on feature from their site. So as you can see in this screenshot, the top figure is what ehow.com looks like before, and later they removed the feature. So we figured that their engineers probably didn't bother to understand what actually happened, so they just removed it. But actually, I just checked yesterday. They've added the feature back, and guess what? It's still vulnerable. So nothing you can do about that. And through a personal connection, we were able to reach another vendor, Hipmunk. And this time, because we were able to contact one of their co-founders, their engineers took it very serious and get back to us very quickly. So the interesting fact is that after they first claimed to fix the problem, SSOScan rerun reveals that they are still vulnerable to the access token vulnerability. what they did is they actually verified the signature of the sign request, but they still pull user information from the access token. Therefore, the fix is basically not correct. So we contacted them again, but the second fix solved all the issues. So as you can see, this is rather disappointing for us to contact the vendor directly. So we've actually contacted Facebook a couple months ago regarding these findings. So for Facebook, they are more concerned about leaking access token through referrer header, as this is directly related to their website, and also any type of OAuth credential misuse. So we reported 95 such cases, which we were able to reconfirm at the time that we reported them. And they have responded that we have notified and taken appropriate actions against those sites. We don't know what exactly that means. They are not willing to reveal any more information. But just a month ago, we did a vulnerability retest on all those 95 sites. We've only found 4 out of these 95 have fixed their issues. So the conclusion here is that SSOScan is able to reveal that roughly 20% of the top ranked websites suffer from these single sign-on vulnerabilities. So it's not very secure. And notifying vendors or even the identity provider are not as effective as one might think. So finally, we think that the best opportunity for SSOScan to deploy is at our app marketplace or developer center, such as Google Play or Facebook Developer Center. And they must be able to shut the application down, revoke its access if they're detecting that the application is vulnerable, because they just don't take it seriously if you report them. So alternatively, it can be deployed as the checking as a service. So this is already happening at ssoscan.org. You can go to that website, submit your application URL, and we're going to run the SSOScan on your website. And with that, I would like to take questions. Thank you.
We have time for questions. If no one, okay.
Murat Kantar, Zhou, University of Texas at Dallas. My question is that you mentioned that your app managed to find 10% of the sites with SSO on it, or some percentage of the sites.
Right, 9.3%, yes.
I was wondering whether you missed some sites. Have you checked for that? Like, did you do a random sample and so on? How do you know the completeness?
Right, so because we tested a large number of sites, like 20,000, we were not able to go through one by one, but we did pick 500 of them randomly, and manually looked at those sites to see whether they have Facebook single sign-on. And I think we've actually discovered maybe there are like 2 or 3 that we missed. So it's like a small trivial number that I think SSOScan will be able to successfully capture most of the sites. And another note here is that because our heuristics, we're only focusing on US sites, so because we look at English login, so we can't, currently we don't do other languages, but it can be easily extended to other languages as well. So.
This is Andrei Kosim from Eurico.
Hi.
Quick question, have you seen any abuse of your service by, let's say, bad intended users or underground? And if not yet, or if have you seen what is your plan? You plan on blocking them or silently monitoring what is their pattern, which sites they look for, and so on?
Right, so the service, currently it has a list displayed on the website of recent test results. But if the site is vulnerable, we actually don't reveal their URL. So hopefully, at least the attacker cannot trivially exploit this. But we also keep a log of who submitted what URL, of course. So I haven't yet seen any abuse of this website. So hopefully that doesn't happen. Yeah.
I think maybe just 2 more questions.
Thank you. Thank you. Hi, Rob Johnson from Stony Brook.
Hi.
So in addition to checking for vulnerabilities, have you given thought to how identity providers can change their APIs or the services they provide so that it's very difficult, it's sort of just hard to misuse or leak? Well, I guess leaking is kind of difficult, but hard to misuse the credentials.
Right. So that's definitely a good question. And so we think that the SDKs, they like some of these vulnerability happen not because like the protocol, there's a protocol error or something. It's just like sometimes the documentation is there, but the developer just didn't read. So I know it's hard for the identity provider to actually do much here. So that's why we have this tool that hopefully the identity provider can take advantage of, so to eliminate these cases. But yeah, it's going to be hard for them to improve the SDK, I think. Yeah.
So we have actually just about two more minutes. So I'll ask a question.
Sure.
Have you given some thought on, or can you tell me how much these are actually being exploited in the wild, or given some thought on measuring or in studying that?
Yeah. We don't really know. So for credential misuse, like because this leads to impersonation attacks, but some of these sites like answers.com or something, like they don't have like very, very high value to exploit, but like match.com, it's like, I think it's very very sensitive. You have lots of information on there. So, but we're not sure whether they have been exploited as of now. So, yeah.
Great. Well, let's thank Yuchen.
Thank you.